Hello there, I'm going to go through AQA's AS Maths Paper 1 from May 2018 today. So first of all, we're told three of the following points lie in the same straight line. Which point does not lie in this line? Tick one box. Okay, well, so we've got this picture where three of these lie in a single line like this, and the other point doesn't. So the easiest thing to do here is to just work out the gradient between any 2 points. So if I take, let's call these A, B, C, D. So if I work out the gradient between A and B, first of all, it's, remember, delta y over delta x for the gradient. So this is 14 minus 8 divided by minus 2 minus minus 1. That gives 6 over minus 1, which is minus 6. So I'll try with the other ones. So what about between A and C? So what have we got there? We've got 14 minus minus 1 divided by minus 2 minus 1. So that's 15 over minus 3, which is minus 5. So they're different. What about A and D? 14 minus minus 6 divided by minus 2 minus 2. So that's 20 over minus 4, which again is minus 5. So these two agree. So that tells us that A, C, and D are all on the same line. Okay, because the gradient between them is always the same. It's not changing direction. So that tells us that B must be the odd one. Question 2. A circle has an equation x minus 2 squared plus y plus 3 squared equals 13. Find the gradient of the tangent. Okay, so differentiate implicitly here. So you get, in the first term, we're going to use the chain rule. So the 2 comes down to the front. Multiply by the derivative of the inner function, which is just 1. So we just get that. Then the second term, we do the same, except we're differentiating y, not a function of x now, so we need to multiply by the derivative. So I'll write y prime there, and then differentiate 13, you get 0. So if you rearrange this, you get y primed is equal to minus x minus 2, take that to the other side, divided by y plus 3. So at the origin, so 0, 0, y prime is going to be minus 2 divided by 3. I'm just substituting in 0, 0 into there. So that's just 2, 3. 2 over 3. Okay, question 3. State the interval for which sin x is a decreasing function if x is between 0 and 360. Well, let's just draw sine. Okay, so where's it decreasing? Between here and here. So that means that x is between 270 degrees and 90 degrees. Okay, notice that it's strictly less than 270 and strictly greater than 90 because at those points it's stationary, it's not decreasing. Okay, so it's only decreasing between those points. 4a is a binomial expansion one, so find the first 3 terms in the expansion of 1 minus 3x to the power of 4. Okay, so generally if we've got 1 plus a to the n, this is true for all real n, then we've got 1 plus na plus n minus 1 over 2 factorial a squared plus n minus 1 n minus 2 over 3 factorial times a cubed, and so on. Okay, so we just want the first 3 terms, and here we've got n is equal to 4 and a is minus 3x. So if we substitute those in, then we get 1 minus 3x to the 4 is 1 plus 4 times minus 3x plus 4 times 3 times minus 3x all squared, so that's your a squared, and then divided by 2 factorial, which is just 2. So then it's just a case of simplifying all that. So 4 times minus 3 is minus 12. And then we've got, well, first of all, 4 over 2 is 2. And then we've got 3 times 3 is 6, and then minus 3 squared is 9. So we've got 9 sixes, that's 54. Okay, now the first three terms. Using your expansion, approximate 0.994 to the power of 4 to 6 decimal places. Okay, so 0.994 to the power of 4, we can think of that as, if we look at our expansion again, that's the same as writing, well, the easiest way to always figure it out is just to equate the two things. So we want 1 minus 3x to be equal to 0.994. So 3x is equal to 0.006. So x is 0.002. So what we want to do is we just want to substitute 0.002 into the expansion. So that's 1 minus 12 times 0.002 plus 54, 0.002 squared. And just use your calculator to do that, you get to 6 decimal places 0.976216. Right, question 5 next. Point C has coordinates C and 2, point D has coordinates 6D. There's another line which is a perpendicular bisector. Find C and D. Probably this is the sort of question where it might help just to draw a diagram. So we've got point C here, point D here, perpendicular bisector, so that means it's perpendicular, it's right angles, and a bisector means it cuts it in half. Okay, so this line is y plus 4x equals 11. Let's just write that in the form y equals mx plus c by moving the 4x to the other side. It's usually a useful thing to do. So what this means is that the gradient of this line is minus 4. So using the idea of the lines being perpendicular, we know that m1, m2 equals minus 1. So that tells us that the gradient of CD must be minus 1 over minus 4, which is a quarter. Okay, but we can also work out the gradient between C and D just using delta y over delta x. So if we take that up there, we've got D minus 2, so that's delta y, divided by 6 minus C, and that's equal to a quarter. Okay, so we're just equating the gradient 1 over 4 with delta y over delta x. If you rearrange that, so multiply by cross multiply, we'll get 4d minus 8 is equal to 6 minus c, and that rearranges after a couple of steps to 14 over 4 minus c over 4. Okay, so we've got one equation that involves d and c. We need another one so we can solve it simultaneously. So what else do we know? We know it's a bisector. So we know that this point here, halfway between C and D, the midpoint of C and D, lies on the line y equals minus 4x plus 11. So let's find, so what's the coordinates of this point? Well, it must just be C plus 6 over 2 and 2 plus D over 2. Okay, so the midpoint is just the mean of those 2 points, the average. So if we substitute that into the equation there, we get 2 plus d over 2 is equal to minus 4 times c plus x over 2 plus 11. So multiply through by 2, we get 2 plus d equals minus 4c minus 24 plus 22. And that rearranges, if we rearrange that for d and simplify, we get d is equal to minus 4c minus 4. So it's a case now of solving this and this one simultaneously, and because I've rearranged them for d, we can just subtract one from the other. So if we call this one equation 1, this one equation 2, then let's do 1 minus 2. And we get, so on the left hand side, d minus d is 0. Minus 4c minus minus c over 4. What's that going to give? I'm going to get minus 15c over 4. And then minus 4 minus 14 over 4. Well, 14 over 4 is the same as 7 over 2. So we've got minus 8 over 2 minus 7 over 2. That's minus 15 over 2. So that gives us c is equal to minus 2. And d, if we substitute this back into one of the equations, so d is equal to minus 4c minus 4, so minus 4 times minus 2 minus 4. And that gives 8 minus 4, which is 4. Okay, so c is minus 2, d is 4. Okay, next we've got a right angle triangle. We're told that D is the point on AC such that AD is equal to AB. So here, so AD and AB are the same. The area of ABD, okay, that's that smaller triangle there, is equal to half of the whole triangle. So first of all, show that tan A equals 2 sine A. Okay, well, let's use the fact that we've got the area of ABD is half of ABC. So let's write that. So what is the area of ABD? Well, we know that the area of any triangle is equal to a half of in words, 2 sides times the sine of the angle between them. Okay, so half. So in this case, ABD is a half of the 2 sides that we know. So that's AD times AB times the sine of the angle between them, which is A. The area of the big triangle, well, it's a right angle triangle, so it's just base times height. So that's just, so we've got a half there already, and then we've got half of base times height. So AB times BC. Right. On the left, AD is equal to AB. We know that they're the same length. We're using that, so we can just say we've got AB squared there. And on the left, a half times a half is a quarter. And then BC, well, if we just use trigonometry, we know that tan A is equal to opposite over adjacent. So that's BC over AB. So BC is equal to AB tan A. And that's how we bring in the tangent. So we've got AB multiplied by BC, but we know that is AB tan A. So if we look at both sides of the equation, we can cancel off AB squared from both sides. And then it's just a case of multiplying both sides by 4 to get what we want. So tan A is equal to 2 sine A. B part 1, show that the equation given in part A has 2 solutions. Okay, so let's start again here. So tan A equals 2 sine A. Well, tan A we know is sine over cosine of A. We cross multiply that. We get that. And then if we move the sine A across and factorize, we get 0 equals sine into 2 cos A minus 1. So we either get sine A equals 0, and if we're in this interval here, 0 to 90, then the only solution there is that A must be equal to 0. Or we have cosine is equal to a half, and again in that interval, inverse cosine of a half is 60 degrees. Okay, so there's our two solutions. And B part 2, state the solution which is appropriate in this context. Well, if A was equal to 0, then we wouldn't have a triangle, we just have a flat line. So it must be A equal to 60 degrees. Okay, it just says state as well, so we don't need to explain why that is. We just need to state that A is 60. Okay, we've got a mathematical proof next. So prove that if n is a prime number greater than 5, then that implies that n to the 4 has a final digit of 1. Okay, well, first of all, what we can say is that the last digit of n to the 4 only depends on the last digit of n. Okay, so I'll just do an example. And this is true for any number, not just prime numbers, any integer. So if we had something like 364 to the power of 4, then we could write that as 360 plus 4 to the power of 4. And if you did a binomial expansion on that, you would have 360 to the power of 4 plus 4 times 360 cubed times 4, and so on, all the way down to the last term, 4 to the power of 4. And what you can see is that all of these terms have a 0, a power of 10 there. So power of 10 to the power of 4, cubed, squared. All of these terms are all ending in 0. So the only term that affects the final digit is this one. Okay, so that shows that the last digit of n affects the last digit of n to the 4. Now you don't need to write all that down. You can just state that that's the case. Okay, so then we just try all the different possible values. So first of all, if n is even, then it always divides by 2. Okay, so that's not prime. Of course, 2 itself is prime, but we're also told that the numbers are greater than 5. If n ends in 5, then it always divides by 5. So again, that's not, well, yeah, so not prime. And again, the only number that's true for is 5 itself, but we're talking about numbers greater than 5. So what other values are there? Well, that just leaves 1, 3, 7, or 9. So let's think about all of these. So if a number ends in 1, then we just got to think about 1 to the power of 4, which is 1. Okay, so that ends in a 1. If we've got a number that ends with a 3, well, 3 to the power of 4 is 81, and that ends in a 1. We've got 7, so 7 to the power of 4. If we work that out, we get 2401, which ends in a 1. And if it was a 9, then 9 to the power of 4 is 6561, which ends in a 1. Okay, so we've tried all possible values. So there's proof by exhaustion. Okay, next one. We've got a relationship between P and V. So P is the pressure of a gas, we're told, in kilopascals. V in litres is the volume of the gas, and somebody believes that there's a relationship, there's power law between them. P equals CV to the D. And we've got a graph of some experimental results. So first of all, find the value of P and the value of V for the data point labelled A on the graph. Well, if we just go along from A along to the X and Y axes and read off the value, then we've got log 10 of P, which is the vertical axis, is equal to, it looks like about 2.18 there. So therefore P, if we anti-log this equation, is 10 to the power of 2.18, which is about 151. V, so log 10V, if we go down, well, that's halfway between minus 0.1 and minus 0.2, so that's minus 0.15. So in the same way, anti-logging that, 10 to the power of minus 0.15 is about 0.708. Okay. In this sort of question, there's usually a range of possible answers whenever you have to read off a graph, but there is a certain amount of tolerance. You can't, if your answer is too wide out, that you haven't read the graph very accurately at all, then you won't get the marks. But if you were out by, say, half a small square, then you're probably going to still get there within the tolerance. 8b, calculate the value of each of the constants c and d. So how do I do that? Well, if I take logs of this equation, so log base 10 of p is equal to log base 10 of c plus d log base 10 of v. Okay, so on the right hand side I've used two log rules. I've got a product c times vd, and also the d can come down as a coefficient. So I get this, and recognize that log base 10 of p is our y, our log base 10 of v is our x value, so that means that the gradient is d and the y-intercept is log base 10 of c. So we'll use that now. So first of all, d from the gradient. So d is equal to the gradient, which I'll call m, in the usual way. So just pick 2 points on the graph, and the best way is just to pick the furthest point apart on the graph, so you're most accurate. So 2.4 minus about 1.97. Now the y values, and then divided by the x values. So the x value at the first point was about minus 0.305, and the x value at the other side is just 0, so that makes it easier. So if we put all of that together, we get about minus 1.41. C is just the y-intercept. So let's just read that off the graph here. So I would say that point is about 1.97. So log base 10 of c is 1.97, and again, just anti-logging to get the answer. And that one works at about 93.3. So estimate the pressure of the gas when the volume is 2 litres. Well, we just substitute these back into the equation then. So P is equal to C, 93.3, times V, that's 2 litres, to the power of D, which is minus 1.41. So I get an answer of about 35.1 kilopascals there. Okay, you might get slightly different depending on how you read the graph, and again, there's a tolerance in that final answer, and that would be within the tolerance. Okay, so the next one is about drawing chords on graphs to approximate gradients. So we've got some quadratic here, x minus x squared. Looks something like this. And we've got 2 points, 3 and minus 6. We're told each chord joins the point 3, minus 6. Let's just say it's there, just for the sake of argument, with some other point. Okay, and this other point is 3 plus h and f of 3 plus h. So that's what we're thinking about here. So first of all, so the collecting data in a table, show where this value minus 5.1 has come from. So how do I calculate the gradient? Well, I use Newton's quotient, which is this, f of x plus h minus f of x over h. So I just put the values in from the table, minus 6.51 minus 6 divided by 0.1. So that's minus 0.51 divided by 0.1, which is minus 5.1. So that's fairly straightforward. Calculate the third row of the table above. So the fourth column, first of all, x plus h. Well, I'm told that in that row x is 3 and h is 0.01, so I'll just add those together. That's easy. Then I need to work out the function at that value. So if I substitute 3.01 into f of x, I get 3.1 minus 3.01 squared. And that gives me minus 6.0501. And so the gradient worked out the same as in the previous question is going to be that value minus 6 divided by 0.01, and that's going to give me minus 5.01 when I do that. State the limit suggested by Craig's investigation for the gradient. Well, you can see it's getting closer and closer to minus 5. Okay, and again, it's state, so you don't have to justify that. And then last bit, using differentiation from first principles, verify that that is correct. Okay, so first principles, we'd say that the gradient is the limit as h goes to 0 of f of x plus h minus f of x. We know x is 3, so put that in. So f of 3 plus h minus f of 3 divided by h. So the function, so we've got 3 plus h minus 3 plus h squared, and then minus the function evaluated at 3, so that's 3 minus 3 squared, and then divided by h. Okay, remember we've got this limit h go to 0 that we need to carry through. Multiply all of that out. So we've got 3 plus h, and then minus, multiply out the quadratic, that's 9, plus 6h, that's, we've got the minus sign in front, so minus 6h, minus h squared, minus 3, and then 3 squared is 9, so we get plus 9. And what always happens with these is that lots of things cancel out. So 3 cancels out with that 3, that 9 cancels out with a minus 9. And we're left with minus 5h minus h squared over h. I'm running out of space here. Minus 5 minus h. And so when we take the limit, let's write that over here. So the limit as h goes to 0 of minus 5 minus h is just minus 5, which is what we stated in part C. Okay, question 10 now. A curve has an equation 2x squared minus 8x root x plus 8x plus 1. Prove that the curve has a maximum point of 1 and 3 and fully justify your answer. Right, well, first of all, we're trying to find a maximum, so what do we need to do? We need to differentiate this function. So y primed is equal to, 4x minus, then we've got 8x times root x, so that's 8x to the power of 3 over 2. Okay, or you could use the product rule if you wanted to, but easier just to do that. So if I differentiate that, I've got 12. So 8 times 3 is 24 over 2 is 12. And then the power goes down by 1, so that just gives x to the half, which is root x. And then plus 8. And then the 1 differentiates to 0. Now, if it's a maximum point, that's a stationary point, so we know that the derivative is equal to 0 at a stationary point. So now we need to solve this, and it looks tricky because we've got x and we've got root x in there. But what we can do is we can make a substitution. So we can put u is equal to root x. So y primed, so x is going to be u squared then. So that's 4u squared minus 12u plus 8 equal to 0. And that is something that we can solve. So divide by 4, we get u squared minus 3u plus 2 is 0. So u minus 1 or u minus 2 is 0. So u is 1 or u equals 2. Okay, so we've got root x equals 1 or root x equals 2. So x equals 1 or x equals 4. Okay, so this is the one we want in this question, is where x is equal to 1. So if we take that value and substitute it back into the original equation to find y, we get 2 times 1 squared minus 8 times 1 times, I'll just write it in full, okay, plus 8 times 1 plus 1. So 2 minus 8 plus 8, so they cancel, plus 1, so 2 plus 1 is 3. So that justifies that the coordinates are 1 and 3. So the last bit is just to prove that it's a maximum. So let's differentiate it again. So 4x differentiates to 4. Minus 12 root x, so 12 minus 12 to the half. That's minus 6 x to the minus a half, so it's minus 6 over root x, and then 8 differentiates to 0. And then we just need to evaluate this at our critical point x equals 1. So we get 4 minus 6 over root 1, which is minus 2, which is negative, so therefore it is a maximum point. Okay, part B, find the coordinates of the other stationary point of the curve and state its nature. Well, I've already done half of that. Okay, the other one is where x is equal to 4. And if we substitute that into y, we get 2 times 4 squared minus 8 times 4 times root 4 plus 8 times 4 plus 1. So what does that equal? 32 minus 32 times 2, so that's minus 64, plus 32 plus 1. Well, 32 plus 32 minus 64 is 0, plus 1, so that's just 1. So the coordinates are 4 and 1. And the nature, well, if we just substitute the 4 into the other equation, into the second derivative, we get 4 minus 6 over root 4. So 4 minus 6 over 2 greater than 0, so that's a minimum point. So that's the pure part of the paper done. Now on to the mechanics. So a couple of 1 markers here to start with. So ball initially at rest is dropped from a height 40 meters above the ground. Calculate the speed of the ball when it reaches the ground. Okay, so just a SUVAC question here. So initially at rest, so we know u equals 0. we know that it's dropping from a height of 40 meters. We know that the acceleration is 9.8. And we're trying to find the final speed, v. So what equation links those together? It's this one. So if we rearrange that with u equals 0, we get v is equal to root 2as. So square root of 2 times 9.8 times 40, which is 28. An object of mass 5 kilograms is moving in a straight line. As a result of experiencing a forward force of F newtons and a resistant force of R newtons, it accelerates. So which of the following is correct? Okay, so we've got some object here. It's 5 kilograms. It feels a force, F forward and R against it, and it accelerates that way. So we know that the sum of forces is equal to mass times acceleration. So if we think about the direction it's accelerating in, there's a driving force forward, there is the resistive force against it, so that's minus R, is equal to the mass, which is 5, times its acceleration, which is 0.6. So 5 times 0.6 is 3. So F minus R equals 3, there it is. Okay, so we've got another part, vehicle, beginning at point P, traveling in a straight line. For the first 4 seconds, the vehicle moves with a constant acceleration of 0.75 meters per second squared. Okay, so let's try and draw this. So first of all, if it accelerates for 4 seconds at that rate, then the final speed afterwards is going to be 4 times. So we've got v equals u plus at. Okay, it's starting from rest, so that's just a times t. So that's 4 times 0.75, which is 3. So after 4 seconds, it's going to be moving at 3, and it's accelerating steadily. So it's going to go up like that to 3. For the next 5 seconds, the vehicle moves with a constant acceleration of minus 1.2 meters per second. So the change in velocity is again going to be the acceleration times the time. So minus 1.2 times 5 seconds is minus 6. So after 5 seconds, 5 more seconds, which is 9 seconds in total, it has dropped, its velocity has decreased by 6. So it will have gone from 3 down to minus 3. Okay, join those up with a straight line. And then after that, the vehicle stops accelerating and travels a further 33 meters at constant speed. So how long does that take then? Okay, so S equals ut. Okay, we don't have a half at squared because a is 0, it's stopped accelerating, so it's just that. So distance is just speed times time. And we know it travels, so we rearrange this for time, distance over speed, 33 divided by the speed of 3. So that's 11. So it travels for another 11 seconds. So in a straight line, because it's not accelerating. So like that. Right. Find the distance of the car from P after 20 seconds. Well, first let's work out the displacement. It's a velocity time graph. So the displacement is just the area under it. Okay, so let's split this up. Use a different color to show this. So I'm going to split this up into just little triangles. It's easier just to do it this way since all the motion is just linear changes, rather than differentiating or trying to find equations of each part of the line. So we just split this up. So we've got, I'll call this A, B, C, and D. So we just need to add those together. So A is half of 4 times 3. The second one, B, is going to be a half of, so what's the base here? Well, it was going from 3 down to minus 3, so this point where it crosses must be halfway between 4 and 9, so that must be 6.5. So it's a half of the distance from 4 to 6.5, which is 2.5. So half of 2.5 times 3. And then C also has a base of 2.5 and a height of 3, so same again. And then D is just a rectangle, so that's just 9 to 20, so that's 11 times 3. So if we put all that together, we've got 6. Oh, sorry, one thing just I forgot there. The 2 that are C and D are underneath the axis, so these should be subtracted as well. So put minus signs in front of those. So I've got 6 plus 3.75, and then the other bit was exactly the same, so that's minus 3.75. So they cancel out quite nicely. And then 11 times 3 is 33, so minus 33. So that gives minus 27 meters. That's the displacement. So the distance is just 27 meters. Take off the sign. Okay, 14, we've got some sort of pulley thing. So particles of mass 1.8 kilogram, 1.2 kilogram are connected by a string over a peg. Initially, the particles are held at rest 1.5 meters above the ground. And then the particles are released from rest. Find the time taken for the 1.8 kilogram particle to reach the ground. Right. So best thing to do problems like this is just to draw free body diagrams for each of those 2 particles. So the 1.8 kilogram one first. Okay, it has a force acting down on it of its weight, which is 1.8 times g, and acting up, okay, is the tension in the string, which I don't know yet, so I'll just call that T. And this is going to accelerate down with an acceleration of a. The other particle has tension acting up and its weight acting down, 1.2 g. This is the 1.2 kilogram particle. And this one, when we leave go, is going to accelerate up because the other one is heavier, so it's going to pull it over the top of the peg. So we write down equations again. Sum of forces equals mass times acceleration. We write that down for each particle. So for the first particle, the acceleration is down, so we'll think about the forces down first, minus the forces up. So 1.8 g minus t is equal to 1.8 times a. Okay, so that's for the first particle. Okay, the second one, it's accelerating up. So we should think about the tension up first, minus the one resisting it, which is its weight. So t minus 1.2 g is equal to the mass times the acceleration. Okay, let's solve these together. So what I'll do is I'll rearrange the second one for t. So 1.2a plus 1.2g. And then I'll substitute that into the first equation. I'll change colour to try and make this a bit less confusing. 1.8g minus 1.2a plus 1.2g is equal to 1.8a. So what we get is 1.8g minus 1.2g, that's 0.6g. And if we add the 1.2a to the other side, we get 3a. So a is equal to 0.6g over 3, which is 1.962 meters per second squared. Okay, So once we've got that, we can just work out the time just using suvat. So the time is equal to root 2s over a. So this has just come from s equals ut plus a half at squared, and it begins from rest, so u is 0. So we've got root 2 times s, so 2 times 1.5 is 3, divided by 1.962, and that gives an answer of about 1.24 seconds. State one assumption you have made in answering part A, so you can talk about things like air resistance, so on. But probably a useful one that really will affect it, is you've assumed that the 1.2 kilogram mass hasn't hit the peg before the 1.8 kilogram mass hits the floor, hits the ground. Okay, so question 15, we've got two cyclists, Laura and Jason. These must be Laura and Jason Kenny, Britain's Olympic cyclists, and they're cycling at a constant speed of 25 kilometers per hour. So Laura in front and Jason closely behind her, we're told. So the driving force applied to Jason is likely to be less than the driving force applied by Laura. Explain why. So if he's really, really close behind her, he's going to be in her slipstream. So he's slipstreaming. So what does that mean? Well, it means that Laura is the one pushing through the air. So Jason feels less air resistance, so less resistive force. So therefore, there's less driving force required to reach equilibrium. (15b). Jason has a problem and stops, but Laura continues at the same constant speed. Okay, part B. Jason has a problem and stops, but Laura continues at the same constant speed. So Laura obviously doesn't care that Jason has a problem. So she sees an accident 40 meters ahead, so she stops pedaling and applies the brakes. She experiences a total resistive force of 40 newtons, and her mass and her bike's mass is 64 kilograms combined. So will she stop in time? Well, first of all, if we've got a force and a mass, we can work out her deceleration. So we've got 40 divided by 64, F over m. So she's got an acceleration of minus 5 over 8 meters per second squared. So will she stop in time? Well, v squared equals u squared plus 2as. Her final speed is 0. Her initial speed was 25 kilometers per hour, so that's 25 times 1,000 meters per hour. So if we divide that by the seconds in an hour, we get the amount of meters in a second. So we got that many meters per second squared. So 2 times a, so that's minus 10 over 8 s. So if we solve that, we get s is equal to 38.6 meters. So will she... Okay, so that's less than 40 meters. So therefore, yes, she will stop before she reaches the accident. State one assumption you made that could affect your answer to part B1. Well, if you see something happening, then you don't react straight away. Okay, so her reaction time means she doesn't apply the brakes immediately. Okay, so she'll travel some distance before she starts to brake. So that will affect the answer. Okay, last question. A remote control toy car is moving over a horizontal surface. It moves in a straight line through a point A, and we're told that this is the equation for its velocity. Find an expression for the displacement. Well, we know that the displacement is the derivative of the velocity. The integral of the velocity. So we need to integrate that expression. So I'll put the 0.06 outside because it's just a common factor. So we can move that outside of the integral, and we've just got to integrate 2 plus t minus t squared. Okay, so we get 2t plus t squared over 2 minus t cubed over 3 plus c. And we've got a boundary condition here. So we're told that initially, so that means t equals 0, the displacement is 3 meters. So r equals 3 when t equals 0. So we're going to substitute that into there. So we get 3 is equal to, and you can see that everything inside the bracket is going to be 0 when t is 0. So we get 3 is equal to c. So therefore r is equal to 0.06 times 2t plus t squared over 2 minus t cubed over 3 plus 3. You could multiply that out if you wanted to, but don't need to. Right, 16b, last question. In this, so at time t equals 2, the toy launches a ball which travels directly upwards with initial speed 3.43 meters per second. Find the time taken for the ball to reach its highest point. So it's just a case of using suvat again vertically. So in the vertical direction, use this equation. So we know that the final velocity is 0. The initial velocity, if we're, let's take upwards as positive this time, so it has an initial speed of 3.43 upwards. Its acceleration is in the opposite direction downwards, 9.8. So if we solve that, we get t is equal to 0.35 seconds. Okay, and that's the paper done. So if the video was useful to you, please like it and subscribe to my channel. And if you're interested in a one-to-one tuition on maths or physics, then please visit my website www.physicsmathstuition.com. Bye for now, everybody.